In this module, we want to find the vector equation of a line. Now, the most important concept about finding the vector equation of a line is that we want to find a vector which starts at the origin and points to a point that lies along the line. It's important to note that this vector doesn't have to lie along the line, but we want to find a vector which starts at the origin and points to a point that lies somewhere along the line. So let's draw some axes. We draw the x-axis horizontally and the y-axis vertically in the usual way. In this example, we want to find the vector equation of the green line. Now let's say that we are given a point on the line and that the coordinates of the point are 12, 14. So one vector which starts at the origin and points to this specific point that lies on the line is this dark blue vector. And we draw our dark blue vector so that it starts at the origin and points to the point 12, 14. You may be asked to find the vector equation of a line which passes through a specific point like 12, 14 here. Here we make the distinction that the coordinates of our point use round brackets, but we use square brackets around a column vector, noting that some courses will write vectors as row vectors. Because points label fixed positions on the plane, but vectors have a length and direction and can be moved anywhere around the plane, we need to use different notations for points and vectors. So we use round brackets to label points and square brackets to label our vectors. So thus far we have just one vector starting at the origin and ending up at our known point on the line. Now, let's say we have been told that a vector parallel to our green line is the vector 3, minus 2, which we draw here in red. We note that the vector is positive 3 units in the x direction and negative 2 units in the y direction. Now we want to find another vector which points to a point that lies on the line. This time we draw a light blue vector which starts at the origin and points to a point at the end of our red vector. This vector will be our dark blue vector plus our red vector. That is, our new vector is the vector 12, 14 plus the vector 3, minus 2. Adding these vectors, we get the resultant vector 15, 12. Let's now imagine that instead of going just one red vector along the line, we go 2 red vectors along the line. Notice here, if we use 2 red vectors, then we are still on the green line. This new vector that points to this new point on the green line is our known vector in dark blue, and this time we add 2 lots of our red vector. So our new vector is the vector 12, 14 plus 2 lots of 3, minus 2. This gives the new resultant light blue vector of 18, 10. Alternatively, we can find a vector back up the line. We could, for instance, produce another vector which points to a point on the line by starting with our dark blue vector to our known point 12, 14, and then add minus 1 times our original red vector. Here we draw negative 1 times our original red vector as a red vector, but in the opposite direction, noting that they are different vectors. The resultant light blue vector will be the vector 12, 14 minus 1 times the vector 3, minus 2 along the line. The new light blue vector will be 9, 16. This new vector also points to a point that lies on the line, just back up the line. Alternatively, we could use the dark blue vector and add this to 3 times our red vector 3, minus 2. Or we could add the dark blue vector to minus 2 times the red vector 3, minus 2, noting that All the resultant light blue vectors point to points that lie on the line. Let's just note that we can use any multiple of the red vectors. For instance, we could add the dark blue vector to 3.6 times the red vector 3 minus 2, or 2.5 times the vector 3 minus 2, or even 0.1 times 3 minus 2. All of the resulting vectors will point to points that lie on the line. So in general, if we start with our known dark blue vector 12, 14, and then add any multiple of the vector 3 minus 2, we will produce a vector that points to a point on the line. That is, if we start with a vector that points to a known point on the line and add any multiple of a vector along that line, the resultant is a vector that starts at the origin and points to a point on the line. Effectively, changing the value of t produces vectors all of which point to points along the line. So finally, to work out the xy coordinates of the points on the line, we simply set our vector expression equal to the general vector xy. Sometimes this xy vector is labelled as the vector r. Using vector notation, we simply write that r vector is equal to the vector p0, which points to a known point on the line, plus some parameter t times a vector v parallel to the line. This is called the vector equation of the line. We note here that we could substitute a value for the parameter t to find a particular point on the line, but for our equation to describe a vector that can point to any point on the line, we must allow t to range over all real numbers. Thanks for watching. Until next time.